Hey guys, in this video I'm just going to be going over the method for sketching graphs of the form A is less than the modulus of W minus B is less than C. Of course where W and B belong to the complex plane, and A and B and C, are real numbers. I'll assume here that you're happy with the basic concepts to do with points in the complex plane, i.e. that you can sort of take an imaginary axis and a real axis, and the point W, which can be written as x plus iy, is simply the point that is x along the real axis, y along the imaginary axis, to give you point W. First thing to bear in mind here is that the modulus function is just simply a length or a distance function. So if you were to write modulus of W is equal to 1, all that's really saying is that the distance from W to the origin for any point W is equal to 1. Which, when you think any point on the unit circle, so if you draw a complex plane, nice unit circle. Apologise for my inability to draw circles. If that's a 1, that's 1, minus 1, minus 1. Any point on this circle is distance 1 away from the origin. So that is the sketch of that function. Now if we wanted to make this an inequality, for instance we want to say the modulus of W is less than or equal to 1, well that's simply all of the points that have a distance less than 1, which is pretty obviously everything that lies inside of our unit circle. So that's, there's nothing particularly special about the inequality, you just have to look whether you've got it here or whether it's on the other side, as to whether you're inside or outside the circle. One thing to just bear in mind in almost a notation point of view is if the inequality is strict, for instance 1 being less than the modulus of W, i.e. the modulus of W is greater, strictly greater than 1, then we draw our circle as a dotted line, as opposed to a solid line, just to indicate that we don't actually include the points on the circle. So the graph of this function would be everything outside of the dotted circle. Now if we have something of the form W minus B, or at least with W minus B modulus in it, that's simply just looking at the distance from W to B, in the same way that mod W you can see as being the distance from W to 0. That's the exact same thing. So if we want to sketch, for instance, the modulus of W minus 1 plus I is less than or equal to 1, where this 1 plus I is our B term, that's a single number in the complex plane, then we would just need to draw a unit circle, like before, because we have distance 1, but we would centre it at the point 1 plus I. So we'd have a unit circle from here, again, apologies for my lack of ability to draw circles, and shade in the middle, because we have a less than or equals to here. And that would be all you need to do to draw the graph for that. So finally, combining all of this, if we want to sketch something of the form that we had in the beginning, that's A is less than the modulus of W minus B is less than or equal to, say, the modulus of C. For instance, here I'm going to sketch a half is strictly less than the modulus of W minus 1 plus I is less than or equal to 1. All we'd do, we'd sketch out our nice complex plane. And recognising that I only really need this quadrant of it, we plot our point 1 plus I, and we start off in reference to this one, a nice big unit circle, just touch the axis. It should be a circle, again, apologies for the fact that it's an egg. And there's our one, our nice unit circle. Now, in reference to this half that we have here, we would simply draw a dotted circle, because it's a strict inequality there, of radius a half, with the same centre point. And then the bits that we are shading in, to indicate that these are the points we care about, are the things that have a radius between a half and 1, which is obviously the bit in between the circle, giving this. And there is your final sketch. So thanks for watching. I hope you found this useful. If you have any comments, or if there's any videos that you'd like me to do in the future on other pieces of maths, please feel free to let me know in the comments below, or let me know on Facebook. Cheers!